Hello and welcome to the video. This is a look at this product from Team Black Sheep. This is the TBS Unify EVO. Now I use the TBS product on the high-end stuff I tend to build just because it's pretty bulletproof. It isn't the cheapest stuff around, but it's stuff that I can rely on when I put it into a model, and I've had really good experiences with TBS stuff. This is the latest one that I've got in, and I've got it in because it's a little bit unusual. You'll notice that as you look at it, there's an awful lot more connections. There's a USB port for one, but there are wires sticking out everywhere. Now this is a pretty standard looking TBS Unify, but it has an extra couple of tricks up its sleeve. It'll go from pit mode up to 800 milliwatts. It's about the same weight as a standard Unify, about 7 grams. It'll run directly from 2S to 6S power, so that's 6 to 26 volts. UFL style socket on the thing itself, and it comes with an SMA pigtail. But the really interesting thing is when you look at it closely, you'll notice that the processor that normally sits on here is an awful lot bigger. This is actually a smart video transmitter, and the extra horsepower in the CPU is being used to do some pretty funky stuff. So I thought it'd be useful when I've been playing with it here to kind of document what I found and how it all works. So if you're not sure about what's different between this and a standard Unify, then you know what the differences will be. So let's just circle back to one of the biggest changes here, which is the hardware. Now the two big headline pieces here are, first of all, that the processor on this now is a 32-bit processor with 256K of memory, and the other Unifys use a much smaller processor. It's an 8-bit with about 1.6K of memory because it doesn't have to do an awful lot. And obviously we have the USB port on the side, but both of those things together with some changes in the architecture mean that this little VTX can do things I've never seen anyone else do. So you can configure this in the standard ways that you would with any Unify. So there's a little push button on the side that you can press to change the power, band, frequency, put it in and out of pit mode. There's also the smart audio connections that you can connect up to a flight controller, enable smart audio out, and then through the Betaflight or iNav on-screen display, configure all those same settings too. There's also, because we have a little USB port on the side, you can plug it into your computer. And using the TBS agent, you can also update the firmware, which is also a really nice touch, and you can access all the settings too. Now in the field, you're not going to use a PC as much, but I love the fact that it's that easy to update firmware, because with a processor this big, then adding features in is just a case of updating the code. But you'll notice that there are cables that will talk CRSF. Now CRSF is the Crossfire Protocol. It's very high speed, very low latency, and is probably something you already have on your model if you're using Crossfire on it. And if you connect those CRSF transmit and receive pins to something else in the model that's sending that CRSF telemetry, it will display that telemetry on the screen. Now that means that you can actually configure the on-screen display using CRSF as well. So you can do some really cool things, like if you have a KISS flight controller that outputs CRSF that doesn't have an on-screen display on board, then you can use one of these and configure one of the outputs for CRSF, connect this up to this Unify EVO, and you get an on-screen display on your KISS stuff. But while we're talking about KISS, one of the other really cool things that they have this little keychain configurator, initially created so that you could change the configuration on your KISS flight controller in the field, but recent firmware updates have also included support for CRSF. So by selecting the Crossfire settings and connecting it up via an on-the-go cable, you can, at the field, also access all the settings as well. But that also means that if you connect this up to CRSF on one of your Crossfire receivers, then you can also access and configure it with the Lua script on your radio, just like you would with the Crossfire and the receiver and everything else that talks CRSF inside your model. Now I've had a bit of a problem with the Lua script here, getting it to run and get it to work, but hopefully I'll get that sorted soon, and if I do, I'll put a post in explaining how I've done it. And the last thing that you can do, if that isn't enough ways to configure this inside your model, it's also configurable by showing a barcode to the camera, because the extra horsepower in that CPU is actually analyzing the image that's coming from the camera. So if you show it a barcode, and the barcodes are downloadable from the website, then it will switch to that particular power, band and channel setting. Now, I'm not sure that's going to be as useful a feature as some of the other connection methods, but I really like the fact that that additional processor is actually looking at the image. It means that you could potentially have some smart image recognition stuff going on that could help with the on-screen display. This is also another step towards what I'm looking for next in the hobby, which is to abandon that horrible ASCII-based on-screen display. Having a dedicated processor like this does mean that you would be able to do simple vector-based on-screen display and potentially do things like context-sensitive alert rather than have your screen cluttered with information all the time to try and spot when something goes wrong. A couple of things to be aware of. Sadly, no support for Mavlink. When this was initially announced, I got really excited. I thought this was going to be the answer I was waiting for things like Pixhawk flight controllers. So at the moment, it's only CRF implementation, but I really hope they get support for Mavlink too. And secondly, at the moment, there is no way to change the on-screen display layout. It is completely set. But let's hope in the future that there's some kind of configuration tool via the agent maybe that you can move things around so you can get it in the way that you want it with the pieces that you want displayed. So hopefully that's interesting for those of you that haven't seen this around. This is a video transmitter with a much bigger brain on board that allows it to do a lot more stuff. I'm excited to see this kind of innovation happening around on-screen displays and excited to see how this is going to progress over the year so that we will have a valid alternative for those horrible ASCII-based on-screen displays that we're used to with the flight controllers that we're using now. Thanks for watching the video and watching right to the very end. You can find me in all the usual places on social media, and if you like the video and like what I'm doing here, then hit the subscribe button and hit the bell notification icon too. If you really like what I'm doing, you can go the extra mile and become one of my Patreons for access to me directly for support and also giveaways and regular updates too. If you're looking for particular content, then check out the playlist. I organize all of my videos into playlists, so if you're looking for a particular topic, you can find everything here. If it's called Introduction To, it's designed to start very simply and build on that simple introduction to teach you all about it. If it's called For Beginners, then that is really aimed at people who are brand new to that part of the hobby. You can also search on YouTube for anything that you're interested in using the search function at the top. So iNav Painless 360 will find all of my videos and even the playlist around iNav. So thanks again for watching and happy flying.